In this video, we're gonna solve more problems on kinematics in one dimension. And we should know that whenever we want to get a value of displacement, velocity, time, and acceleration, these formulas right here are the things you needed in order for you to get those values. Now let's try to apply these formulas right here into some problems. Now for this example, a bicycle is traveling with a final velocity of 47 kilometers per hour and accelerates for 9 kilometers per hour squared for 3.7 hours. Now, what is the total distance traveled by the bicycle, and what is the total displacement traveled by the car if it traveled for 2.3 more hours? Now, first thing to do is that whenever you have a problem like this, you have to identify first the given variables. Now, we should know that the bicycle is traveling with a final velocity of 47 km per hour. So therefore, our final velocity is 47 km per hour and accelerates for 9 km per hour squared. So therefore, our acceleration is 9 kilometers per hour squared and for 3.7 hours. So therefore, our time is actually 3.7 hours. Now, what is the total distance traveled by the bicycle? So therefore, what we're trying to look for is the displacement. Now, which of these formulas right here are we going to use that have your final velocity, acceleration, time, and displacement? We should know that these three formulas right here are the formulas that we have to, or these are the formulas that are possible to be used. But we should also know that these formulas require the initial velocity, which is this one, and this one. And we do not have yet the value of initial velocity. So therefore, let's try to find first the value of initial velocity using this formula. Now let's rewrite the formula. So final velocity is equal to initial velocity plus acceleration multiplied by time. Now your final velocity is 47, where your initial velocity is what we are trying to look for, and acceleration is 9 multiplied by your time, which is 3.7. Now 47 is equal to initial velocity plus 9 multiplied by 3.7, then you should have the value of 33.3. Now we have to transpose this one right here. So 47 minus 33.3 is equal to initial velocity. So 47 minus 33.3, then we should have the value of 13.7 is equal to initial velocity. So therefore, our initial velocity is actually equal to 13.7 km per hour. Now we already have the value of initial velocity, so we can now find the value of displacement. Now let's try to use this formula. Now we write the formula. Now we know that displacement is equal to initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. Now displacement is what we're trying to look for, and 13.7 multiplied by time, which is 3.7, plus 1/2, and acceleration is 9, and time is another 3.7 squared. Now 13.7 times 3.7, then you should have the value of 50.69 plus 1/2, 9, and 3.7 squared is actually equal to 13.69. Now again, 50.69 plus 1/2 multiplied by 9 multiplied by 13.69, then you should have the value of 61.60. Now 50.69 plus 61.60, then you should have the value of 112.29. So this should be our final answer for letter A. So therefore, our displacement is actually equal to 112.29 kilometers. Now another question. Now what is the total displacement traveled by the bicycle if it traveled for 2.3 more hours? So we should know from our initial time, which is 3.7 hours, the bicycle traveled again for another 2.3 hours. So in order for us to get a total time, let be your total time is actually equal to T1 plus T2, where your T1 is actually 3.7 plus your T2, which is actually 2.3. Now 3.7 plus 2.3 is actually equal to 6 hours. Now we have to look how long did it travel for 6 hours using the same formula. Now let's try to do that. So again, your formula displacement is equal to initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. Now distance is what we are trying to look for, and initial velocity is 13.7, where time is 6, plus 1 half, where acceleration is 9 and time is 6 squared. Now 13.7 times 6, you should have the value of 82.2 plus 1 half multiplied by 9, and 6 squared is 36. Now 82.2 plus 1 half multiplied by 9 multiplied by 36, then you should have the value of 162. Now 82.2 plus 162, you should have the value of 242 or 244.2 kilometers. So therefore, for the second displacement, the total displacement it traveled is actually equal to 244.2 kilometers. So for this example, a bicycle can travel 112.29 kilometers within 3.7 hours with a final velocity of 47 kilometers per hour and initial velocity of 13.7 kilometers per hour and with an acceleration of 9 kilometers per hour squared. And now, the bicycle can also travel 244.2 kilometers with a total time of 6 hours and with the same final velocity, initial velocity, and acceleration. So that is how we do it. Now let's try to have another example. Now for this example, a horse is running in the track at a constant speed of 28 kilometers per hour in 28 minutes. Then the horse started to accelerate at 4 kilometers per hour squared for 8 minutes. Now what is the total distance traveled by the horse within 20 minutes? Now we should know that we have to look for the distance it traveled within 20 minutes. And that 20 minutes is actually separated by two parts, which is actually your 12 minutes and 8 minutes. So in this case, we actually have two parts. First is your 28 kilometers in 12 minutes and the other one is 4 kilometers per hour squared for 8 minutes. Now I want you to know, or I want you to keep in mind that whenever we have a kind of complicated problem, it is better for you to visualize it first. Now, again, this is your horse, and we know the horse is going to travel for two parts. So first, the horse traveled for 12 minutes, and for the second one, the horse traveled for another 8 minutes. Now we have to identify the value of the total displacement of the horse traveled, which is this one. But in order for us to get the total displacement, we have to find the displacement for the first and second part. So let be your first part is equal to d1, where d is actually equal to displacement, and for your second part, you have d2, where d is again displacement. And so total displacement is actually equal to d1 plus d2. Now let's try to focus first on the first part. Now again, we have to identify the given variables. We should know that the horse is running at a constant speed, so therefore our velocity is actually equal to 28 kilometers per hour. And again, it traveled for 12 minutes. Then we have to look for the displacement. Now again, whenever you have a constant velocity, this formula right here are the formula that we are going to use. Now again, displacement is equal to velocity multiplied by time. Now displacement is what we're trying to look for, where your velocity is 28 and your time is 12. Now 28 multiplied by 12, then you should have the value of 336 kilometers. So therefore, the horse can travel 336 kilometers for 12 minutes with a velocity of 28 kilometers per hour. So therefore, our d1 is actually equal to 336 kilometers. Now let's try to look for the second one. Again, identify the given variables. Now we know that the time is again 8 minutes. And then the horse started to accelerate for 4 kilometers per hour squared. So therefore, our acceleration is 4 kilometers per hour squared. Now again, initially the horse has a constant velocity of 28 kilometers per hour. But we should know that the horse started to accelerate already. So therefore, we should know that the initial velocity is actually equal to 28 kilometers per hour. Now, which of these formulas right here are we going to use? We could actually use these two formulas right here. But however, these formulas require the final velocity, which we do not have yet the value. Therefore, we have to find first the value of final velocity using this formula. Now again, final velocity is equal to initial velocity plus acceleration multiplied by time, where final velocity is what we are trying to look for, and initial velocity is 28 plus acceleration is 4 multiplied by time is 8. Now 28 plus 4 multiplied by 8 is actually equal to 32. So 28 plus 32, then you should have the value of 60. So therefore, our final velocity is actually equal to 60 kilometers per hour. Now we can identify the value of displacement. So let's try to use this formula in order for us to get the value of displacement. Again, final velocity squared is equal to initial velocity squared plus 2 multiplied by acceleration and distance. Now final velocity is actually 60, so squared, where initial velocity is 28, also squared, plus 2, acceleration is 4, and displacement is what we're trying to look for. Now 60 squared, then you should have the value of 3600, and 28 squared is actually equal to 784, plus 2 multiplied by 4 is 8, and d. Now transpose this one here. Now 3600 minus 784 is equal to 8 multiplied by distance. Now 3600 minus 784, then you should have the value of 2816 is equal to 8d. Now isolate your displacement by dividing both sides by 8. Now 8 here divided by 8 here also. Now cancel this one. So 2816 divided by 8, then you should have the value of 352 kilometers is equal to displacement. So therefore, the displacement for d2 is actually equal to 352. Now using this formula right here, let's try to identify or to get the value of our total displacement. So total displacement is actually equal to d1 plus d2. Your d1 is actually equal to 336 and your d2 is 352. Now 336 plus 352, then you should have the value of 688 kilometers. So this should be our final answer. Now the horse with a constant speed of 28 kilometers per hour can travel 336 kilometers in 12 minutes, and the horse started to accelerate at 4 kilometers per hour squared for 8 minutes, then it can travel 352 kilometers. Now therefore, the total displacement traveled by the horse within 20 minutes is actually equal to 688 kilometers. Now let's try to have another example. Now for this example, a car is traveling at 4 miles per hour squared with a final velocity of 7 miles per hour. 1 hour later, the car is traveling at a constant speed of 18 miles per hour for 0.35 hour. Finally, the car speed up again for 5 miles per hour more than the initial velocity and covered a distance of 48 miles. First, how long did it take the car to travel 48 miles? B. What is the total distance traveled by the car? Now we should know that we actually have 3 parts in this kind of problem, but in order for us to properly visualize the concept, let's try to graph this one or to draw this one. So this is your car, and this will be your first part, second part, and third part. Now what we are trying to look for is the total distance traveled by the car. So again, this distance right here is what we are trying to look for. Now again, using the same concept from the previous problem, we should know that this will be your displacement 1, displacement 2, and displacement 3. So your total displacement is actually equal to d1, d2, and d3. Now let's try to focus first on the first part. Now identify the given variables. We should know that the car is traveling at 4 miles per hour squared. So therefore, our acceleration is 4 miles per hour squared with a final velocity of 7 miles per hour. So therefore, our final velocity is 7 mph. Now 1 hour later, the car is traveling at a constant speed of 18 miles per hour. So therefore, after 1 hour, the car have been traveling with a constant speed. So therefore, our time here is 1 hour. Now let's try to identify the displacement. Now we could actually use these 3 formulas right here. But again, we do not have yet the value of initial velocity, which is needed for us to be able to get the displacement. So therefore, let's try to identify first the initial velocity using this formula. So again, final velocity squared is equal to initial velocity squared plus 2 multiplied by acceleration and displacement. Now final velocity is equal to 7 squared, where initial velocity is 3 squared, plus 2, acceleration is 4, and displacement is what we are trying to look for. So 7 squared is 49, and 3 squared is 9, plus 2 multiplied by 4 is equal to 8, and displacement. So transpose your 49 right here. So 49 minus 9. Now 49 minus 9 is of course 40, is equal to 8 multiplied by displacement. Now divide both sides by 8, then cancel. Now 40 divided by 8, then you should have the value of 5. So therefore, for displacement 1, we actually have the value of 5 miles. Now let's try to go on with the second part. Now identify the given variables. We know that the car is now traveling at a constant speed of 18 miles per hour. So therefore, our velocity is 18 miles per hour, and it traveled for 0.35 hours. So therefore, our time is 0.35 hour. Now again, what we're trying to look for is your displacement. Now again, since we have a constant velocity, the formula that we are going to use is this one. So simply, displacement is equal to velocity multiplied by time. Now displacement is what we are trying to look for, and velocity is 18 multiplied by your time, which is 0.35. So now 18 multiplied by 0.35, then you should have the value of 6.3 miles. So therefore, the value of our D2 is again 6.3 miles. Now let's go on with the third part. Again, identify the given values. We know that finally the car speed up again for 5 miles per hour more than the initial velocity. So therefore, from our initial velocity, which is actually equal to 18 miles per hour, because before it is speed up, its initial velocity is again this one, this 18 miles per hour. So therefore, our initial velocity is 18 miles per hour. So it speed up for 5 miles per hour more. So therefore, our final velocity is 18 plus 5 is just simply 23 miles per hour. And it covers a distance of 48 miles. So therefore, our displacement is 48 miles. So for our G3, we already have the given value, which is 48 miles. But the question here is, how long did it take the car to travel 48 miles? So therefore, what we're trying to look for is your time. Now we could actually use this formula right here to get the value of our time. Now let's rewrite the formula. So again, displacement is equal to 1/2 multiplied by final velocity plus initial velocity, then multiplied by time. Now displacement is actually equal to 48. Now 1/2 final velocity is 23, initial velocity is 18 multiplied by time. Now 48 is equal to 1/2 multiplied by 23 plus 18, then you should have the value of 41 multiplied by time. Now 48, 1/2 multiplied by 41, then you should have the value of 20.5. Now multiply or divide both sides by 20.5. Now 48 divided by 20.5, then you should have the value of 2.34. So therefore, for this problem or for this part 3, the time is actually equal to 2.34 hours. Now for the last part, we have to look for the total displacement traveled by the car. So using your formula again of total displacement is actually equal to D1 plus D2 plus D3. And your D1 is actually equal to 5 plus 6.3, and where your D is 48. Now 5 plus 6.3 plus 48, then you should have the value of 59.3. Then this should be our final answer. So therefore, the car have traveled 59.3 miles within 3.65 hours, because we have to add this R right here, this R, and this R. And that is how you do it. Now let's try to have another example. So for this example, John and Peter are 250 kilometers apart, and will meet within 3 hours. Now, John is traveling with a constant speed of 13 kilometers per hour, moving east, and Peter is moving west at unknown speed. Now, first, how fast is Peter traveling? B. How far did each of the two friends traveled? Now, let's try to visualize it first. Now, this should be your Peter, and this should be your John. And they are actually 250 meters apart. And John is actually moving east with a constant velocity of 13 kilometers per hour. And Peter is moving west with an unknown speed. Now, first, how fast is Peter traveling? So therefore, again, what we are trying to look for is the velocity of Peter and how far did each of the two friends travel. So therefore, we should know that these two people are gonna meet somewhere between this distance or somehow here, or we don't actually know yet first. But we should know that both of them are going to cover a certain displacement. So again, let your John have the first displacement and let have your John or Peter have your second displacement. And so they are going to meet within 3 hours. So therefore our time is 3 hours. Okay? Now again, whenever we have a constant velocity, this formula right here are we going to use. Now let's try to apply this one for John first. Now again, displacement is equal to velocity multiplied by time. Now for John, we are going to use d1 is equal to velocity 1 multiplied by time, because again, d1 represents John and velocity 1 represents John also, but time, they have the same time, which is 3 hours. Now displacement 1 is what we are trying to look for, and velocity 1, which is 13, and multiplied by time, which is 3. So 13 multiplied by 3, then you should have the value of 39 kilometers. So therefore, our d1, which is actually equal to 39 kilometers. This is for John. Now let's try to focus now for Peter. Now again, displacement is equal to velocity multiplied by time. Now for Peter, we have d2 is equal to v2 multiplied by time. Now displacement 2 is what we are trying to look for, and velocity 2 is what also we are trying to look for. Now we have 3. So this should be our equation. So simply d2 is equal to 3 multiplied by velocity 2. So again, displacement 2 is equal to 3 multiplied by velocity 2. Now we should know that total displacement is actually equal to d1 plus d2. Now your total displacement is actually equal to 250 plus or equal to d1, which is 39, and d2 is 3 multiplied by v2. Now transpose your 39 here. So 250 minus 39 is equal to 3 multiplied by v2. 250 minus 39, then you should have the value of 211 is equal to 3 v2. Now again, multiply or divide both sides by 3. So 211 divided by 3, then we should have the value of 70.33 is equal to v2. So therefore, the velocity of Peter is actually equal to 70.33. Now going back to this formula right here, we can now identify the displacement traveled by Peter. So again, displacement 2 is equal to velocity 2 multiplied by time, where displacement 2 is what we are trying to look for, and velocity 2 is actually 70.33 multiplied by time, which is 3. So therefore, 70.33, then you should have the value of 211 meters. So therefore, the displacement covered by Peter is actually equal to now 211 meters or kilometers. And that is simply how we can do it. Now again, for this example, John and Peter are going to meet up within 3 hours with a total displacement of 250 kilometers apart. Now John has a constant velocity of 13 kilometers per hour, and Peter has a constant velocity of 70.33 kilometers per hour. And John have traveled 39 kilometers while Peter have traveled 211 kilometers. So now if you want to check if we actually have the right answer, we're just going to add this one, and you should have the value of 250. So 39 plus 211 is actually equal to 250. So therefore, this should be our final answer. And that is how you do it. Thank you for watching.